I think what people might be having trouble with is when we have polyatomic ions. So a little review, look in your notes to find the list that we made. What might be helpful is actually when you have the equation written out like this, put a parentheses around the polyatomic ion. For example, here we have sodium phosphate, so I'm going to put a parentheses here. I'm actually use a different color, right? So that means that I'm counting this as one unit, right? So we'll say this is A and that's B, okay? So two separate things instead of saying three separate things. No, it's just two. And then here, OH, so that's hydroxide. That is a polyatomic ion. So we have C and D here. Okay, so we have A, B, C, D. And then what happens on this side of the equation? So we have NaOH again. So it's A and D plus PO4, phosphate, is one unit, which we said was B, and K was C. So using an arrow, I like to show, okay, what actually happened here. If we noticed, B and D swapped, right? So these two switched places, right? If you look here, that's what you end up with. You swapped. So if you have a double-headed arrow, which means two things are switching, that's double replacement. Double swap, right? Wife swap. They swap places. Two things swap places. Okay, so I think the trick there that people might be getting stumped on is the polyatomic ions. So when you see multiple things, you're like, what's happening? But just keep it as one unit and you'll be fine. So H, we'll do the next one. H here, let's do the same thing. So we have magnesium and chlorine. So that's clearly A and B. And you don't have to put A and B. I'm just doing that to show you. It's simpler to explain it that way. And then we have lithium here, so C, and then, oh, another polyatomic ion. And if you don't remember them, use the list that we made. That's why we made a list. So CO3 is carbonate. We'll call that D. So we have AB, CD, and an arrow, and then here's carbonate. So we're going to put parentheses to remind us that is one unit. We have AD plus lithium and chlorine, CB. Same thing. See? These are the same. So what should H be? It's also going to be double replacement. Let's look at I. Okay, this kind of equation is my favorite. If you see O2, it is combustion. That's the trick, okay? If you see O2, it's going to be combustion. And, well, most of the time, it's going to be combustion. But especially, it's O2 with some kind of CH molecule, it's definitely combustion. And the products will always be carbon dioxide and water. So combustion is actually the easiest to identify. But if you see this O2, it's very likely it's combustion, 99% of the time. All right, and then P, so this can also get funky because if in the notes I put, right, A plus B, if it gives you AB, it's synthesis, which this is synthesis. And maybe you got confused because you see, okay, well, there's two things here. That's totally true, but it is one unit. So when I put these letters, I'm talking about a unit. Is it one molecule? Is it one thing together? Are we counting it as one? Yes. So even though this is, we'll say instead of A and B, let's make it what it is, right? This is A, B, and C. But the final result is what? It's ABC. So as long as it's going from separate to all together, that is synthesis. Okay, even if one of the molecules has multiple parts, that is fine. Okay,